specifically the string design of PV inverters. We don't do central. So we've actually taken that success and we've moved it over into our battery system, which we'll touch on here shortly. Yeah, so right here is essentially what we have for our battery offering. So that top bit is going to be our 5 megawatt hour best container. So that's going to be a 20-foot HC standard container. And then that 2.4 megawatt string skid is also 20-foot size. And that's going to be what's actually doing, the DC to AC, AC to DC. That actually comes with a transformer on it, which is super interesting and something we can talk about a little bit later when we get to kind of the dynamics of the market and some of the pain points that people are seeing right now. We're actually able to kind of get around a couple of those pain points because we will incorporate all of the balance of systems into that skid for you. So that skid is comprised of those 200 kilowatt PCSs. So to explain this a little bit further,
should I go to the next slide now?
Yeah, go back real quick.
Yeah,
right there. I was just going to say, to explain that, we can dig in and talk about how that actually connects to the battery later, and how that gives you that string design. On the bottom is our CNI, so our smaller scale, which you can see we have the 125 output and the 250 output. And those are also very interesting. When you get to the 250, you actually get into a bit of a string design there as well. So like I said, we're taking all that knowledge that we got from the PV string inverters and we brought it over into our battery system. The goal being easy installation, quick commissioning, and less downtime in the long run. I did a white paper the other day that was like a central BESS inverter versus our string design. And if you run it out for a 20-year lifespan, if you run it out on a 20-year lifespan, you see that if there's one or two instances of failure, really you just need one instance of failure from that central inverter to make it not worth your money versus a string design system. So a lot of people are like, oh, well, string, PCSs are going to be more expensive. They're really not. But if something were to happen, you're only losing one little bit of your output. You're not losing your entire BESS container. So super interesting.
Yeah, let's dig into that. And essentially, like these product lines on the utility side, the 5 megawatt hour LFP container and the 2.4 megawatt hour skid, and the CNI products are essentially your day-to-day responsibility areas as a solutions engineer. So you talk about these solutions and their key benefits all the time, I assume. So yeah, let's dig into those key benefits. I guess this slide is where we can start digging in a little bit more, huh?
Yeah. So I put this slide in here to kind of give a reference point of what a normal installation might look like. Obviously we have our PV inverters, our breaker box fuses, all that stuff, even medium voltage transformers. That's all going to be on the PV side. But the main thing I want to point out here is that point of interconnection, which I kind of alluded to this a few minutes ago when I was talking about some of those pain points that people are seeing. Those pain points I was talking about was the transformers. So with our PCS skid, you get a built-in transformer. And that transformer can be 12 kV to 34.5, right? So whatever you essentially need it to be, we can make it. And we can get you that in 6 months, when most people are finding that transformers right now you can't get for 9 months or a year. So that alone is kind of a huge benefit that we're seeing. It's actually been really nice for us and our customers. But with that ability, we can pretty much interconnect wherever you want us to, right? Since we have that wide range of outputs. So that's really what I wanted to showcase right here. And then also you see that there's 2 battery containers going to 1 PCS skid. So that's what we would call our 4-hour model. So 10 megawatt hours of capacity and 2.4 megawatt max output. That actually can be increased a little bit. but for all intents and purposes, 2.4 megawatts of output right there. And obviously, we can derate that as well if we needed to. But this is kind of a standard looking design that we would see on some of these larger scale systems. This is similar to what we just saw for the utility, but this one's going to be focused on the CNI. You can see this one's behind the meter. So the CNI system has actually been fantastic for us. We actually had an older, smaller battery system that we sold for a little while, but we've moved on to the 125 250 now. And then we obviously have some stuff coming out in the future, which I won't touch on today. But just some nuggets for you guys, you know. What you're seeing here, though, is going to be kind of a standard setup. Obviously, with CPS, we can provide a large majority of this. In fact, the only thing that we can't provide, I would say, is the diesel generator or your loads. So on the solar side, obviously we have our PV inverters, and we actually have a sister company, Astro Energy, which makes PV panels. So that they're also owned by Chint. So you can get that all from CPS or our sister company. And then the energy storage system, obviously, like we're talking about today, is going to be from CPS. One cool thing, though, that we've done on our CNI system specifically is we have a partner called Alexity that we work with for our EMS system. Now, I want to make it very clear that for the energy management system, we are agnostic. We have a local controller in the backside of our PCS cabinet that you can hook up any energy management system that you want to, and basically gather that data, control the system, whatever you need to do. However, we've realized that in the market right now, a lot of people want a one-stop shop, right? So we provided that through our partner Alexity. And we can talk about some of Alexity's stuff later. Very interesting company. They have some great different things that they can do with their system as far as controlling loads dynamically and whatnot. It's just super, super cool stuff. But as I was saying, in this scenario right here, you could, from CPS, you can get our PV inverters, you can get our energy storage system. From our sister company, you can get the PV panels. Go somewhere else for the diesel generator. That's about it. But we can even do, so this is showing what we would call a grid tied system, right? In this scenario, standard 125. Most of the time, this scenario would be used for basically peak shaving or shifting of your high demand. You actually see this a lot in California now. So we have a couple sites and scenarios where people have like a large building and they've had a decent amount of solar panels put on it, say in the past, right? Well, now with NEM 3, all these new projects, even some of those that were just finished up, they're not getting anything when they're selling their back to the grid.
Well, I mean, hopefully they got live back in NEM 1 or NEM 2 days.
That's what you're hoping. But if you didn't,
if you missed that window and you have to finish it in NEM 3 rules, you're a little bit out of luck and monetizing that. So you definitely need to integrate batteries now to make best use of your electrons.
It's crazy because I didn't put a slide in here. I should have that shows a graph of it's kind of like an estimated graph of what your energy buyback price would be under NEM 3.
It's a small fraction of what you were getting before.
It's atrocious. I mean, there are times when you're not. I mean, you're getting a tenth of a cent. It's like, okay, well, I'm basically it's basically costing me money, you know.
But you can't blame the utility companies for that because they're they have so much supply of energy in the middle of the day when solar is cranking, and